welcome to another lesson at EduSolutions Institute. Now, today's lesson will be looking at the CSEC physics syllabus, and we'll be continuing on the basis of action of forces, the effect that forces have on objects. Sorry. Now, the topic for today will be the center of mass leading into moments of a force introduction. Now, what is the center of mass? The center of mass of an object is the point where all the masses of the object acts. So therefore, if we have a bar just like this here, and we suspend it at the middle part of it, we notice that it's not moving left or moving right. So hence we say that it is in equilibrium. Now, this equilibrium position means that we have equal masses on the left side, equal masses on the right side. So therefore, the center of mass is in the center of this object right here. So the center of mass is that point that creates that balancing effect when suspended at that point. Now, what happens if we put an object on one side? We notice now we have more mass on the right side, so it causes the object to fall down to the right. Now, this raises the question of the topic of moments, because moment of a force, or some books will have it as torque, is the turning effect that a force provides. So notice, as soon as we apply a force, it causes this lever to turn. So therefore, this principle is called moments. Now, what will make this bar in equilibrium? One is that the forces going down has to be equal to the forces going up. So let's show you an example. If we put a force here and we put a force here, it's going to make it balance. So we have two downward forces. Now, where is the third force? Because there has to be an upward force to balance off the effect of these two forces. And that upward force will be at the pivot point, because the object is in contact with a pivot, so it will generate an upward force on your pivot point. Now, you notice as well, if I move one of these to a different position, it makes it unbalanced. And this is because that leads to the second condition for objects to be in equilibrium. So the first one is that opposite forces will be equal, right? So in this case, the sum of the downward forces will be equal to the sum of the force going upwards at the pivot point here. Now, the next principle is the principle of conservation of moments. That tells us that the moments that's causing it to turn to the clockwise rotation, which is this one on the right, must be equal to the moments that causes it to rotate the anti-clockwise motion, which is that one. So when we put the moments of both clockwise and anti-clockwise together, and they're equal, then we get a balancing effect. Now, how do we find moments? Moments is defined or calculated by multiplying the mass times the gravity, so that gives us the force that the object has, multiplied by the distance it is away from the pivot point. So in this case, the distance away from the right side is 1.75. The distance of the left side is 1.75. They both have the same mass, so they will both weigh the same amount of weight, and hence they will be positioned at the same point to make it equilibrium. Now, what if we introduce a second object? Notice it's now unbalanced. Can we balance this with just the 1, 5? No, we can't. What if we put these two 5 here? There is a point where we can actually get this to be balanced. And this point is right here. So this 110 kilograms that's on the left side, rotating it anti-clockwise, is balanced off by the two 5s, one place at 0.25 and the other place at 1.75. So this shows us that principle holds true regardless of what the forces are acting. Once you can balance off the moments, which is a turning effect by each object. So if we put the bin here at 2 meters, then that means if we use the weight, which would be 100, because it's 10 times gravity, which is 10. So 100 times 2 is 200. So therefore, the moments that's generated on this side, so each of these objects, 5 kilograms, would weigh 50 newtons, because it's a 5 times gravity, which is 10. So this is 50, and we need it to be 100. So therefore, we need it to be 200, sorry. So therefore, if we put that one at 2, so it's 50 times 2, which is 100. So therefore, this one has to be placed at 100 as well. It's not at 100, it's not at the 2, sorry. So we cannot balance it. If we move this one a little bit more in, right, and then we'd have to move these and we get that balancing effect. Because what we know is that the 100 newtons of the bin times 1.5 will give us 1,500, right? 150, sorry. That's the moment of the bin on the clockwise rotation. The anti-clockwise would be the 50 Newton times 1, so that's 50. And the 50 newtons times 2, that's 100. So we get 100 plus the 50, and that gives us the 150. That's rotating it anti-clockwise, and we see that the object is balanced. Now, these are the two principles that will help you to understand why objects will turn and be balanced, and why objects will not turn when they are placed on something that is suspended. Now, this is a principle in which a seesaw operates, that if the two objects are of different mass, to balance it, we have to put the larger one closer to the pivot point, and then we put the smaller one away from the pivot point. All right, so we notice here the 10 is placed closer to the pivot point, and the 5 is placed further away from the pivot point, and it gives us the balancing effect. Now, we will continue this on our next class, where we'll go more in depth in how the principle of conservation of energy, momentum, works. So, thanks for watching, and I hope you understand a little bit more about center of gravity as well as moment of a force. And I'll see you next week. Thank you.